I'm Shashi Bala, and I welcome you all to the day second of India Smart Utility Week. Please excuse me for my bad throat, but I extend a very warm welcome to each one of you in the session Unified Energy Interface and the Evolving Era of Energy Internet. To set the stage, may I kindly invite the chair and moderator of the session, Shri SK Chatterjee, sir, Chief Regulatory Affairs, CERC. Sir, please come forward and grace the stage. We have Anirban Sinha, Senior Associate Open Markets Innovations from FIDE. Anirban, please come forward and take the stage. Take the seat. Next, we have Mohit Kumar Sethi from KrypC. Welcome, Mohit. Now, it's my honor to welcome our esteemed panel of speakers. We have Ms. Laura Sandys, former Member of Parliament, UK and CEO. Ms. Laura, please, welcome, ma'am. Next, we have Shri Abhishek Ranjan, CEO, BRPL. Abhishek Ranjan from BRPL. Request Abhishek to please come forward and take the seat. Okay, no problem. We'll go ahead. Ms. Lydia will be joining us virtually. We have Mr. Dog, Executive Director, NREL. Welcome, Dog, and grace the stage. Yeah. Sorry, I missed Raviji. So Raviji is also here. He was not well. So I'm not calling you to sit, but he'll be definitely a part of our discussion. Yeah. We have Miss Arshi Chadha, co-founder Trillectric. Welcome, Arshi. I request everyone to please clap for her. Yeah. Next, we have Mr. Himanshu Chawla from PFI. Request Himanshu to please come forward and grace the stage. Okay, he's not joined yet. So we'll just wait for a minute for the two of our speakers are not, and then we'll start, yeah? So yes, with this now, I request our moderator of the session to take the session ahead. Thank you so much, and all the best, sir.
Good afternoon, everybody, and I think quite a heavy panel with so many panelists, and we possibly are expecting more participants as we move along. So I understand the structure of the session is that we will have a base presentation by Anirban and Ravi both, I think. And then I think you have the introduction about the panelists already in the brochure, so we won't spend time on introducing the panelists. So I would suggest we start with the base presentation first, and then after we have heard the two speakers, we then go over the other panelists here one by one, and I'll also definitely make broad observations right at the outset after the presentation. So I think, can we have the base presentation from Anirban and Ravi quickly? Yeah.
Can that be put on the screen? Hello, good afternoon, everyone. I have been given a tough job of summarizing UEI in 6 minutes. I failed to do so in 60 minutes, but I will try that. So the theme of the session is Unified Energy Interface, right? UEI. and the evolving era of energy internet. So what I will try to do, I have 6-7 minutes. I will split it in two parts. I will give you a broad overview of what UEI is. Basically, what's the philosophy, what's the design principles of taking that way. And then I will talk about a specific project that we are doing with ISGF along with Arshi and others who are here in the panel in UP. That's a peer-to-peer energy trading project, and probably we will see how these principles, how the design principles of UEI fit in the context of P2P energy trading. Can I have a clicker, please? Thank you. With that, I will quickly go into the introduction. So this is the foundation that I come from. It's Foundation for Interoperability in Digital Economy. It is promoted and founded by Mr. Nandan Nilekani, who is chairman of one of the biggest IT firms in India, Infosys. Dr. Pramod Verma, he is like a digital veteran. He had been the chief architect of Aadhaar, which is the identity system of India, digital identity system of India, UPI payments, FASTag, DigiLocker, and many other things, and Mr. Sujit Nair, who is the CEO and co-founder of the foundation. So they have been working together for a good 15 years since the days of Aadhaar. And if foolishly I try to attempt, summarize their learnings of what they have done over the last 15 years, these are the three things. I mean, again, disclaimer, this is a foolish attempt. You can't summarize 15 years in 3 points, but these are the 3 broad things that come out as a playbook for us. If you have to design something for the population scale, if you have to design something for the scale of 1.3 or 1.4 billion people, you have to design for diversity, which means, think about internet. When internet was, getting designed, 1990s, 1985s, nobody thought there will be a ChatGPT today, right? Or nobody thought there will be a Tinder after 25 years. But it was designed in such a way that it can accommodate these innovations 25 years, 30 years later. So that's designed for diversity. Can you see the unforeseen and put it in your design principles? Then the second principle that we design with is distribute solving. We believe that at least for a country like India of 1.4 billion people, you can't do everything on your own self, right? So you have to create structures where many market players can come in and solve. So basically, instead of solving it yourself, can you distribute the ability to solve? And that's what we have seen in the case of UPI as well. UPI could have been a platform, like a Visa or a MasterCard, but it was not a platform. It was designed in a way of a protocol so that a PhonePe can come in, a Cred can come in, Amazon Pay can come in, or Google Pay can come in and start innovating. I don't know how many of you know WhatsApp does payments in India, and that's the first geography where they have started doing payments because of a protocol that can accommodate many players to innovate on top. We also believe in a +1 thinking, which means you can't change behaviors overnight. So you have to do something which is acceptable and small and then move from there. So with these design principles, when we started applying this to the context of energy, we started seeing that there is a huge place for creating one digital infrastructure for all things energy. And please don't confuse this with a IEX or an energy exchange. This is basically where anything related to energy can be transacted. So I'll explain. This is the tough part, but imagine what you see on the screen is a network. Okay, it's called UEI. In India, it's called Unified Energy Interface. There are many digital energy elements which are connected to this network. You have a EV charging operator connected to it. You have the EVs connected to it, the solars connected to it, the households, batteries, and so on. You have the grids, utilities, discoms also connected to it. This is an ideal state. But if this happens, what are the benefits? In India, you have almost 78 charge point operators, CPOs. All of these charge point operators have their own platforms, right? On top of that, there are aggregators. So basically, if you go to the Play Store or an iOS App Store, you will find there are 100 applications which is flooding India's App Store to support the EV owners. So now, if I have to go from a Bangalore to Mysore, what are the 5 applications that I should install to ensure that I can get access to all the charging points between Bangalore to Mysore? That was the problem statement that we started with, and we realized that instead of creating one platform, can we create something like a network where all the service providers, if you see from the bottom side, GeoBP is one of the service provider, Charge Zone is one of the CPOs in India, Tata Power is one similar. All these are, for illustrative purposes only, by the way. But if you create this kind of a network where many service providers can connect from the other side and all the consumer applications can connect from the other side, this creates an opportunity for any player to come to this network and give and overall access to the users, which means you don't have to jump between 5 applications to find out where the charge points are. You can come to even a small app like WhatsApp, share your location and find out where all the, nearby within 5 kilometers or 10 kilometers where the charge points are. It can be even going forward integrated to your dashboard as well, so that you don't have to initiate an action. The moment your SOC is below 20%, the dashboard can start finding in the network where are the nearby charge point operators, the charging stations, and can start redirecting to that. Similar is the case for solar. I mean, I was here in during the last panel, and everybody is saying that, okay, we have a nice subsidy program, we have a nice aspiration of so many households to be solarized, but we are somewhere getting stuck during the implementation because our systems are not very unified. The systems, if you think of the manufacturers, the installers, the subsidy provider, whom the state or the center, or even the financiers, they don't talk to each other. They have a very siloed ecosystem. So the idea was, can we bring all these people to one network to give a unified experience to the people who are trying to consume these services. So going back to the earlier diagram, this is what UEI is in a nutshell. Can I create a general purpose energy digital infrastructure where all elements related to energy transactions can get connected and we can do transactions on top? What is needed to do that? The first thing that is needed to do that, all these edges, the people that you see at the edges, they have to talk in a common language. I don't have to speak about protocols and language in this room because I know you guys know it way better than me. So what are the common standards and protocols that we can develop that ensures all these parties, when they interact, can interact in a smooth, unified way? That was the attempt. So this is basically an example, right? I mean, we can speak or understand each other because we are conversing in a common language, which is English or Hindi, whatever it is. But if I start speaking in Bengali, who doesn't understand Bengali, a person, he will not be able to understand. The same is the case for electrical standardizations. Somebody said that, okay, India is going to have a 230 volt, 50 hertz standard output from a plug point. That's why the appliance maker could come up and build anything from a toaster to an AC. So this kind of standardizations help in market expansion. Same we have seen for the digital cases, TCP, IP, HTTP, UPI, all these are digital standards on top of which we have expanded the market, like the case of internet, like the case of UPI, and so on. So we said that, can we design a protocol which will support this kind of economic discovery and transactions, and that's where Beacon came in. So FIDE is the organization that I come from. Beacon is the protocol that we work on, and the network that you saw in the last 2 slides is called Unified Energy Interface. I know it's very confusing, but that's pretty much the relation between all 3. Now, the very next logical question is, there are so many standards already in the market. Are you creating a competing standard? That's not true. That's not true because Beacon doesn't compete with any of the standards that are there already in the market. You have the OCPI standards, you have the OpenADR standards, IEEE standards all there. Beacon allows you to virtualize and put all the standards on top of a unifying layer. What do I mean by that? The best analogy will be, let's say internet. If you have to transfer a image file, the standard that you use is generally JPG or JPEG. If you have to share a media file, it can be an MP3 or an MP4. But does TCP/IP, on top of which the whole internet packet system is built, come as a competing standard to JPEG? No. TCP/IP accommodates all these standards to make those transfers happen. So Beacon is that unifying layer for our OCPI to interact, for our OpenADR to interact, for our IEEE standard to interact. So this is basically the visual representation of it. Can you create one digital layer on top of which all these standards can be unified? So pretty much what we are trying to say is Beacon is the TCP/IP equivalent for the digital energy world. Quick jump cut. So this is the idea of UEI. We have 50 plus organizations who finds merit in this idea, and they have created an alliance called UEI Alliance. This is the spectrum of that alliance. We have many people like think tanks, financing companies, people who are building like Arshi, Trillectric. I see Vani from Kazam there. They are all a part of this alliance because they believe there is merit in this thinking. So what I'm trying to say again and again, this is not a new platform. This is not a new idea. This is just a shift of thinking. This is a way of thinking to accommodate all the existing platforms and new innovations. What has UEI achieved over the last 1 year, 1.5 years? We are currently in the, I think the runway was like what, one year, 1 month. There are already 50 plus members. They are collectively transacting, I think 16,000 transactions a day. The cumulative transactions have reached somewhere around 3.2 million transactions. So it's not just an academic idea, it's happening on ground. Where are the cases coming from? The cases are coming from EV. The cases are coming from peer-to-peer energy trading, demand response, on-demand storage, and these are the people who are kind of activating those markets. This is where I will shift very quickly to the P2P energy. Okay, sorry, by the way. This is a vision paper that we released very recently, 12th of February, along with IEA. I think Lydia is also here, who was also a part of this whole effort. This is basically creating a global vision out of this idea. So UEI, if UEI is the manifestation of India, you can consider digital energy grid to be the backbone, the global vision behind it. So the QR code is there. You guys can probably scan and read this paper whenever. It's a 70-page paper, sorry, but whenever you get time. So this is the peer-to-peer energy trading network that we are trying to build in UP. Uttar Pradesh is a state in India having so many discoms. So the idea was, if you have to scale peer-to-peer energy trading beyond one discom to 28 states, 8 UTs, what should be the design? With that question, we started thinking, can UEI fit in the concept of peer-to-peer energy trading? And when we met Register, the whole ISGF team, they found, they were already experts of this whole forum and initiative. They have already, I think by that time, done 3 or more than that projects, actual pilots. They saw merit in this model because this helps you to scale way beyond pilots and one state. Because if you see, this is a complex diagram, but just focus in 3 layers. There is a transaction layer, there is a infrastructure layer, which we also call the data trust layer, and there is the utility systems. If you look at the top transaction layer, this is where different apps come in. What do I mean by that? There is Trillectric, there is Pulse Energy, there is Kazam, there can be a PhonePe tomorrow, there can be a Google Pay tomorrow, who come in and say that, okay, I will bring in the prosumers, I will bring in the consumers, and I will make them interact with each other. So this is basically the marketplace where people buy and sell. But it's not only a digital intent of buying and selling. By the way, okay, peer-to-peer may be a new terminology for many people. So peer-to-peer is basically, I have excess, I am a prosumer, I have excess energy, I am not going to be there in the town for, let's say, 3 days, or I know that my solar panel is going to produce for 14 units, but my daily consumption is only 10, can I sell those extra 4 units to someone else? One of the opportunities is, of course, to sell it back to the grid, but it's always not economically effective. So can I sell it to one of the peers who is willing to pay a better price? So this is the marketplace where people, the prosumers and consumers come in and they interact with each other. But the critical part of this is, it's not only a transaction, right? You have to validate those transactions, which means there has to be a trust conduit between the utility systems and the transaction layer. So if I am saying that, okay, I will give you 5 units, what's the guarantee that I have given you 5 units on the next day? For that, you need the whole metering data. What is the time block based data coming from the metering system? That's what the infrastructure layer does. The infrastructure layer works as a conduit between the discom utility systems and the transaction layer to pass on this information, number one. Number 2, also the vice versa of it. The discom also needs to know what was the actual trade that has happened, what has been sealed off, which means how much should I adjust in my electricity bills. If I have, say, traded something with Shashi, 5 units, it will anyway get recorded in my net meter, right? But somebody has to do that adjustment. So for that, discom need that trade data. So this layer also works as that conduit to send it back to the discom and so on. So we call it data trust layer or infrastructure layer. And definitely there is this utility system layer which has all the meters, MDM systems and so on. If you see, the whole reason of creating such a complex structure was to ensure that you can infinitely scale this top layer. If there is a new UT, there is a new state that you are getting in where these players are yet not active, you can just activate another digital player who is there in the market and overnight onboard him to this layer, because everybody is basically speaking to in the same language. He doesn't have to come and integrate with 7 other pointers, right? So the whole integration is taken care of through one common language or a protocol. And this, of course, the trust layer is also aware of that language. So all these things are UEI aware. I think, Mohit, you are going to explain the whole architecture anyway. So that's where I will stop. I can take a couple of questions, reflections, but pretty much the takeaway that I want you guys to go away with, that how can we decrease the cost of transaction at a population scale? Second is, how can we democratize access for many people? I may not be, so this happened with Spotify. I mean, for some reason, my UPI payment was not working, so Spotify cancelled my subscription. Now, if I have to go back to Spotify, Spotify is saying that, okay, you have defaulted on your payment, so I'm not going to give you subscription. I'm pretty much stuck because I don't have another app who can give me such a rich, collection of songs. This kind of network structures kind of disbands that monopoly. It says that, okay, the providers on the other side, you can come to those providers through any application. It's not one platform who will only give you this access. So basically, you can infinitely scale those platforms. And of course, the third layer, how can you how can you design for diversity? So with that, I will stop. Any reflection, questions, or I will pass it on to our moderator to go for the next session, maybe? Yeah. Thank you.
Yeah, thank you, Anirban. I think very good context setting, and I think we can have you have a presentation? Yeah. Yeah, so we can have, I think Ravi has some throat problem. So Mohit, yeah, please carry on, and then we'll get going.
Yeah, hello everyone. So it was nice to understand about the various technical aspects and different how in the energy landscape. I will be talking more about the observability layer, trust layer, and some basics on blockchain again, and try to connect all the things. And I'll spend some time initially on the flow of information in the architecture we just concluded. Okay. So this data flow diagram, it is very similar to where Anirban had ended his slide, right, where the three layers were there. Now, before we get into why blockchain, like how blockchain is ensuring data trust in the overall ecosystem, it is good if we take a step back and understand a little on the data flow, where the data is flowing in the ecosystem. So in a very simple sense, every producer and consumer through various aggregation services, what we have BAP, BPP, etc., right? So they come into an agreement. So there is an agreement between two parties that I am offering some energy at this price or reverse. So this is one of the most fundamental data element, or you could say a contract element in real world, that is being agreed between two parties, and it is very important data, and it would definitely be stored in the respective application through which the initiation have happened from the user point of view. But overall in the ecosystem, this data is critical in terms of the future actions which are going to happen in terms of transfer of funds or settlement, etc. So this is one of the data which will continuously keep coming. And obviously there are other data, for example, what are the offer, what are the trades, based on certain logic they may be there, not be there. Now the second most, and which is always like keep coming, is the meter data reading. Meter data reading together with the agreements between two parties is the fundamental logic behind like whether we have to execute things on the basis, okay, what two people have agreed, and then the meter data reading, which can be like 48 times per day, right, etc. Now this data is very important, because based on this data only, logic would be applied by various systems, or I would say services in the ecosystem, to complete the delivery of the services, right. And then we have things like billing information, KYC information, etc. So they are very important in terms of KYC, like who are the people who are participating and whether we have got the authorization from them, etc. So it's not from the data flow perspective, but it is for enabling various stakeholders that they are interacting with an authorized services, right. So now I will get into how blockchain works, and then I will be able to connect it with this like complete process, right. Now let's get into let's think like we are talking to a magic invisible layer. Now here think about, instead of a centralized box where all the data is stored and everyone is accessing it, think of it as a decentralized storage, and it is protected using decentralized blockchain ledger technology. How we can always discuss, but the core part here is who are the participants, right? The participants are in this ecosystems are consumers, producers, prosumers, the applications, BAP, BPP, the smart meter data providers, and similarly the obviously the heart is the discoms. All those are connected. Some may be connected directly, some may be connected indirectly. For example, in the current context, the end users are not directly connected to the storage or observability layer, but they are connected through the various interfaces. The whole idea is the data gets synchronized here. In the next slide, you will be able to understand. So the first thing is like you would have seen authentic, and we have seen the key like symbol coming here. It is basically, I am trying to say it's cryptography. Cryptography comes into picture here. So anyone who is interacting with this system, whether to write data or read data from the observability layer, the blockchain layer, they are having specific public key, private key, public key, etc. And then only they are able to write data to it or read data from it. So there is a complete control, and within the participants who have access to it, it is completely transparent, and only they are able to access information or write information on it, right? The second thing is authentic. Authentic means by the technology itself, the blockchain distributed ledger technology, the way it replicates information, it's like very authentic. If something happens in any of this four nodes, what we are able to see here, right? Anything happens, it gets quickly replicated, and it's very easy for anyone to infer that this information is authentic because it was related to the previous section of they were first onboarded to this system and they have their own cryptographic keys. So that means the information is quite authentic and it have come from the right source, and that means I have the authentic information. Now transparency is one important factor in blockchain. Now when we think about the normal ecosystem of Bitcoin, Ethereum, etc., it is like completely transparent. Whereas when we are talking about the way we are working in this model is basically it is transparent within the ecosystem. So whoever are the participants, within them the data is completely transparent, and to have certain privacy features, specific controls are available either within the blockchain or the application interface using which the observability layer is exposed to, ensuring that the data privacy and confidentiality are taken care of to the extent possible. So when I say efficiency is again it's smart contract driven and other optimized logic which are like configured on the blockchain. So you can think of disintermediation. So when there is a process happening without blockchain, so there is an intermediary which have to do certain things, and it have to publish that information to the various stakeholders in the network, not just in any of the application. Whereas efficiency in blockchain is like automatic. If there is a for example demand and supply matching, or there is a credit debit which have to be done together. In conventional system, one account is first debited and the other account is credited, and atomicity is a challenge, and there is always a trusted third party whom we agree on. Blockchain not only resolves that problem of atomicity, also make it quite efficient. Now we are able to see in the screen the red cross. Basically this is again a very important part of it, and one of the very reason our current implementation is highly related to this particular feature is immutability. So when multiple participants are talking and they will store data in their databases or their backend, there could be discrepancies with the information, for example, the agreements or the timing or the timestamp, etc., or anything, right? So they need to have a common mechanism using which they all agree that the data, what they see in the for example, this layer is the final. So how it is done is, it's one of the principle of blockchain by design, using its consensus and cryptographic I would say design. So if one of the participants where the infrastructure is being hosted and we try to manipulate any data, it will be easily identified by other majority of the nodes that this is not correct, and that transaction would be discarded. And there are chances that it is either done intentionally or unintentionally because of some hardware or networking issues. So in the later case, that person, the node from where the bad transaction have occurred, they would rectify, resync, etc. In the earlier case, if the node operator, for example, intentionally is doing something which is not desired, there are ways in blockchain where that particular node becomes blacklisted and it becomes like people, the other nodes leaves connection with that. So immutability is very important, because any data, obviously using blockchain technology, digest technology, how cryptographically two blocks are linked together, there are various articles which we can understand. But the whole thing is, even bad actors within this network, if they are lower than the tolerance level of the network design, they will not be able to manipulate the network. So our data is completely immutable. So automate is again a feature where certain actions in logical world, we would have done a transaction. Let's say if 2 transactions have happened and now we have to do settlement, or we have to do certain actions, how smart contracts with blockchain technology can automate many of the things. So it reduces a lot of integrations and development which systems have to do. Okay. And high availability. Now data is the fundamental, I would say, asset in many applications. In our application as well, it is I would say the core asset, because there are multiple agreements, multiple metadata coming, and KYC information, etc. This data is so vital to us that if it is stored in one place, and there are ways to have high availability other, but we need a way in which data is immutable plus highly available. Blockchain and the correct, if it is configured, it is the best architecture or best technical solution using which we can achieve this. Now since the data is replicated in this particular screen with 4 nodes, anytime one of them or 2 of them are down, we have the data available. But in production scenarios, obviously we will have, let's say, 8 nodes, 10 nodes, 20 nodes, 30 nodes, and there are some mathematical formulas using which we will ensure that at least the majority of the participants are always active, and there are alerts mechanism, so that we always ensure that we are never going to lose the data. And this is one of the most important part of an application, and with so much volume of data being exchanged between participants. Now just to conclude on the architecture, I will just revisit the data landscape. In the previous architecture, I was talking about how data is getting more. So we have communications between BAP, BPP, right, and the reverse, and there are agreements between consumers and producers, prosumers, etc. And then later they will have payments, whether the payments are done. So these are different types of data which flows in the network. There are order books, there are validations that the 2 parties have agreed. Meter reading will obviously eventually be the most, I would say, the largest data set, as the number of participants and as the number of consumers and prosumers who participate, and they are going to anyway increase. So it will eventually become the largest data set. And then billing and then how billing compute is done. Now with smart contract in my previous slides I was explaining, so it will help us in understanding, for example, how do we associate. So for example, between two parties there was X amount of energy which was supposed to be traded. It can be in reality because of how the nature is working, how the environment is, or their own personal reasons, they would have consumed more energy. There could be deviation. Now how these deviations have to be calculated. So blockchain having its data from the agreements, the data from the meter reading, it is easy for it to do the allocation first using FIFO, LIFO, etc., and then it can do the deviation calculation and make it available, and every party will agree to it because the agreement data was provided by the respective applications, and the meter reading data is coming from the meter data aggregation services, and the smart contracts is basically completely auditable. So before everyone joins the ecosystem, they are able to understand the rules which are embedded in the smart contract. Okay, this is the agreement and this is the actual data from the meter, and these are the different rules which we have agreed on, how deviations would be calculated, how allocations would be done. So it will become very easy for them, everyone to agree, and they'll be able to easily understand, okay, this is the reason this much payment have to be done, this much deviations have to be done, and complete transparent informations would be provided to the DISCOM so that they would be able to easily integrate it with their monthly or like in prepaid daily or in postpaid monthly, they'll be able to take this information and adjust the billing. So it will also help the DISCOM, it will also help the end user to understand that what are the different elements in their billing and how this summary is coming, right? And obviously the rule engine. So with this basically I'll end it, and if any other queries which may have, we can either have in this session or outside also. Thank you.
Thanks, Mohit, for your presentation. Now I think turn to a panel discussion. I hope you have no presentation. You have
I do, but it's very crazy, so it's fine.
So it's fine. I mean, then we can go ahead with your presentation.
I'm sorry.
Let's
I
first.
will be-
Mhm.
Thank you.
5425.
Thank you. Just wonder whether. My name is Laura Sands, and I am from the UK, chair of the government's energy digitalisation task force, and a real advocate and proponent of digitalisation in the energy sector. When we started this journey, we had quite an amusing time with a lot of the energy sector itself, and I was asking one of the chief executives of one of the distribution networks, tell me about your digitalization capabilities in your company. And he said very sweetly, oh, we had a very good guy who rolled out Microsoft Office. So I started to realize that we had quite a gap in terms of understanding and knowledge. And I love my colleagues in the energy sector, but when it comes, certainly in the UK, to technology, innovation, and digitalization, we're probably about 35 to 40 years behind other sectors. Thank you. Can I move on to the next? Oh, right. Oh, fantastic. Oh, I didn't know I was in control. So what are we talking about? This really is, I mean, in many ways, I'm going, let's say, more strategic than the fabulous presentations we've had. And I'm absolutely, I knew I was coming to India to learn, and I've certainly learned something today. But what I was going to explain was actually the overall strategy of how we looked at the digitalization journey. So I have someone in the middle of this very, very changing environment. And that person could be the regulator, it could be the DSO, it could be your minister, but fundamentally, we are talking about a new complex energy experience. In the UK, there are 400 people who run the energy sector. I don't know how many people in India run the energy sector, but we are moving, and all these 400 people, they know each other's wives' and husbands' names. They know what dates of the babies' birthdays, etc. This is a very intimate little club, right? And we are moving to 100 million actions and assets. Every EV car can do 3 things. This interaction, the dynamics of what the energy sector is going to look like are absolutely inconceivable for those chief executives who currently run the energy sector in the UK. And some of the areas that we talked about in our digitalization task force, and I'm sure you've looked at this, but from a regulatory point of view, how are we going to look at the cascade of algorithms on the system for the system to be resilient? How are we going to include financial services into the energy sector whereby we are allowing assets to be distributed and deployed more effectively? I'm afraid I always have a fridge because fridge is storage, and we're going to need a lot of different storage vectors on the system. But as you can see, we are talking about a very changed system, which will need, as much as anything, a culture and mindset change. Because certainly in the UK, we have an energy system that is absolutely focused on economists and engineers, and they both come together, the 2 E's come together, and they create perfect situations that actually, when the rubber hits the road in the reality, is just not reflecting what people do. So, talking about this, so we're looking, and our strategy address the multiple and changing consumer preferences. We talk very clearly about a customer passport. And that customer passport in many ways reflects exactly what you were talking about. As I have these different assets, these are then taken, and I own the control. Significant interaction between different parties. There is nobody who's going to be in control. This is a distributed, multiple-layered set of transactions, contracts, and market arrangements. Just-in-time data needs to be given to new actors. When I asked the energy sector how much contact they had with the EV manufacturers, they said, oh, well, we've met 1 or 2 people from the trade body, but we don't really understand them. Well, that's not really good enough. And then you've got the more dynamic and bi-directional, the V2G stuff, lot of issues around electrifying industry and how industry can also deliver. So if anybody, and I know nobody in this audience thinks so, but we have a little bit of inertia, I would say, in the UK, they think that they can layer a digital layer onto their existing processes. And that really worries me, because they will go around telling everyone, oh, we've digitalized, oh, that's fantastic, and everyone will give them a round of applause. But actually, digitalization is about changing processes. It's about changing your business model and how you do things, not just ensuring that one has faster communications. I will finish by just talking about the tools that we suggested the UK government, and they have totally adopted them, although the implementation is a little bit of a problem. Customer control and consent. This, in some ways, is the customer passport. Automated asset registration. Every time I go past a hotel or whatever, my mobile phone automatically offers me that Wi-Fi. Why are we not utilizing existing systems to actually auto asset registration? In the UK, you have to register your EV car in 5 places. A flexibility exchange. But fundamentally, and I think I've got the answer from today's presentation, we would call this the digital spine, and this is being able to have what I would call the use case is prices to devices. And that means an offshore wind farm being able to communicate with an EV car. Now, not that they will communicate, but that you have what we would call HTML of energy, a very, very, very thin layer of interoperability that doesn't consume other people's business models. And my very last point is, how many people in this room come from other sectors other than the energy sector? Is there anybody? Oh, fantastic. Great. Because everything we are going through in the energy sector, the transition, has happened in other sectors. And the more that we can get people from outside the sector to teach us the lessons, to deliver us the digitalization. I mean, you look at all of these, this is all, you know that Tesco can tell, 40 years ago, it could tell a woman whether she was pregnant or not before she knew it, due to her purchasing habits. That is something the energy sector has no knowledge of its customers in that granular way. And I think it's a very exciting time, but I urge you to recruit people from other sectors because there's nothing new here. Thank you very much.
Wonderful. Yeah. I hope you don't have any presentation, Arshi? No? And Mr. Arent, you have any presentation?
I will serve you not. So I will talk and not show presentation.
Yeah. Achha, there is one online?
No, I will not show a presentation.
Okay, so online we have Lydia has joined already. So can you hear me, Lydia? Hello.
Can you hear me?
Yeah. Now we can hear you. So, would request you to make your presentation or observations on the theme of the session today.
Sure, I do have a presentation. It will be very short.
I would request you in the interest of time, would request you to be
yes, of course,
to be brief so that we engage in lively discussions. Yeah. Okay.
Yes. Are you able to see my screen? I'm not sure.
We can see you.
No. Oh, you can see me. 1 second then. Oh, share it again. Entire screen. You're able to see the presentation?
Yeah, we can. You can expand.
Yeah.
It. Yeah. Okay. Please
Can
go
you
ahead.
see it?
Please. Yeah.
Yeah.
Does it come there? Yeah, it's not full screen, but yeah. Yeah. Okay. Done. Please go ahead, Lydia.
Okay, perfect. I just wanted to give, I mean, we've been talking about the energy sector and how it is slow to change, slow to transition, and how fragmented it is. So I think it would be useful for the discussion to have a little bit of an overview on the energy sector. Just a quick introduction. My name is Lydia Jaykumar. I work at the International Energy Agency, and we've been doing a lot of work at the IEA about digitalization, decentralization, and how like growing demand, rising electrification is really changing the electricity sector, changing the energy sector to make space for ideas like the UEI, like DEG, different kinds of ideas that connect different parts of the energy sector, which is already very fragmented. One of the main takeaways from our World Energy Outlook, which was our flagship report, was that we are in an age of electricity. By 2035, the IEA expects global electricity demand to grow 6 times faster than overall energy demand. This graph will show you, how each different sectors, the share of electricity is basically going to really change and increase in a drastic level. This is in the net zero scenario of the IEA, but in all other scenarios, we see a similar kind of change. This slide, I thought it was useful to see like how we envision future distribution grids to look like. maintaining electricity security in power systems of tomorrow will call for new tools and approaches, which we've already talked about today. Power generators need to be more responsive and agile. Consumers will need to be more connected and adaptable. And grid infrastructure will need to be strengthened and digitized to support more dynamic flows of electricity and information. Power systems also will need to adapt to changing climate, weather patterns, changing consumer behavior. And this expansion means that maintaining electricity security is very, very challenging. There is progressive electrification of road transport, heating, industrial processes, and all of these will really reshape load curves and make demand more variable. And on the other side, increasing use of air conditioners, heat pumps, for example, will make demand more temperature sensitive. And also, like, there is proliferation of EVs, which increases the risk of rapid variation in demand caused by charging or uncontrolled charging, as we often call it. At the same time, we know we are also witnessing remarkable transformation in how energy is generated and how electricity is generated more specifically. In 2024, 80% of new power generation capacity came from low emission sources. And solar PV is obviously leading the growth in this area. This year alone, or last year, by this point, the world added enough solar capacity to power the entire country of South Korea. So this is extraordinary opportunity, and it allows us to deliver more energy at a lower cost while also reducing emissions. But this opportunity is really not possible without the interoperability and flexibility that we have been talking about today, that systems like the UEI and other interfaces allow us to provide. And this is also the biggest challenge. The need for flexibility in our energy system has really never been greater. And we need flexibility from not just one source, we need it from every source. We need it from a different range of solutions. So we need battery storage, we need demand response, we need advanced technologies that can connect millions or even billions of devices across our grids. This is why the IEA believes that digitalization truly shines. As previous presentations have already talked about. A united energy interface is a system, we're imagining a system that links everything from electric vehicles to air conditioning units, creating new flows of data, new markets, new incentives. This is the kind of transformation we need to build a system that is flexible, resilient, and future ready. One of the reasons the IEA was also keen to contribute to the work of FIDE on the digital energy grid is for the idea and the opportunity it provides for system-wide efficiencies. So not sectoral efficiency, which is different parts of the energy system being efficient separately, but system-wide efficiency. In 2024, an estimated 83 billion connected devices and sensors will be creating large, diverse data sets on a wide range of topics like energy consumption, air quality, traffic patterns, different topics. And energy efficiency through digitalization is powerful in a dense urban context. Next generation energy systems can leverage the data from these connected buildings, appliances, transportations, assets to reduce energy consumption, improve grid stability, and better manage city services. And at the end of the day, the IEA is a data agency, and one of our big recommendations for a lot of the new changes that is happening in the energy system is the importance of data, which is what I will end by stressing on. All of the ideas that we have today is not possible if we do not bridge the data gap. The energy system is already quite a fragmented system, and data availability, data accessibility, data usability, which is being able to use the data for different use cases, data quality, data standardization, which is transferring transparent standards for data, being able to transfer it, and interoperability, which is ensuring that varying sectors, assets, and actors can actually use the data that is being shared. This is the key to unlocking the issues in the energy sector for the next generations. Thank you. Stop sharing.
Lydia. Thanks, Lydia, for your very insightful presentation, and thanks for bringing energy sector onto the table. And because just before you, Laura was mentioning about non-energy sector players to be playing an important role or a better role in, training the energy sector professionals to, in terms of the ways as to how to go to the next level of revolution in the energy sector, the kind of revolution that is happening and that is expected possibly cannot come from the engineers and economists she mentioned. You need some thinkers beyond engineers and economists. That was quite interesting, but good to see some slides which are very commonly used by energy sector specialists. I am also, in fact, feeling out of place here and surrounded by mostly the non-energy sector professionals, but good to have this discussion. Good that we already have presentations from most of the speakers. We are left with 2 more panelists, but before we get into the panel discussion and subsequently open house from the participants here, let me give you a broad perspective. What Lydia mentioned was in terms of the broad world international scenario in terms of the energy sector, how energy sector is growing. I'll bring the India perspective, India, and what we are talking about in terms of the UEI and the blockchain and others. The focus is on the distributed energy resources. That's the terminology that we use in energy sector. Largely all that you are talking about, whether the electric vehicles, the battery energy storage systems, the rooftop primarily, they all form part of what we call the distributed energy resources. They are likely to proliferate extensively and exponentially as we move forward. And how to integrate all of them meaningfully and with ease is what these layers in terms of the UEI and blockchain would actually do. And it's really true that the energy sector and the energy sector professionals have a lot to learn from this world and try and integrate, because most of us are used to physical systems and cannot really think beyond the physical transfer of electricity, and that there is a world. And in fact, I come from the Central Electricity Regulatory Commission. We are a central regulator in the electricity sector here. This was the kind of experience that we faced when we brought in this concept of the power exchanges. In fact, that was also a kind of a new novel kind of otherwise you generally would do one-to-one trading. So way back in 2006-07 when we came up with that. So that was also kind of a new and a novel thing, but still, at the end of the day, I mean, while that platform helped aggregate the demand and supply across the country, the physical flow continued to happen through the infrastructure that was already laid. So physical and the other interface which actually helps the physical flow and also creates the ease for transactions between the consumers and the suppliers is what basically. So this is the next level of revolution that we are going to go in. And some broad figures, as I said, we already have about 16.65 gigawatt of distributed, largely the rooftop solar already in place, and we have the target of 40 gigawatt by 2026. So you have huge potential in terms of integrating all of them through whatever protocols, whether it is UI or your blockchain. So a lot is coming, and not only the rooftop, we have other potential candidates in the form of the electric vehicles. And several other new concepts are coming up, and Lydia did mention about the virtual power plants, or I think Mohit's presentation also had so many terminologies which we are accustomed to. We are talking in terms of what we call demand response, because more often than not in the energy sector, we think more in terms of the supply side interventions. If the demand is growing, the first focus goes on how much capacity addition do we need to make. Rather, the current focus is on reducing the demand or optimally utilizing the demand to overall reduce the power procurement from the market. So grid connected large scale solar, of course, they are to come because the growth is exponential in India. The demand has been growing exponentially at around 6% and likely to go further higher up. So on the demand side, what is it? So when we talk in terms of the demand response, you basically tend to tap this untapped and unharnessed resource to manage the variability of the grid. While we are talking in terms of 500 gigawatt of intermittent renewable to come in the energy sector by 2030, as regulators, we have a very difficult job of managing the grid. So physical infrastructure will remain there, complexities have to be managed. But in this whole process, if the distributed energy resources and the demand side interventions come, and the technology really steps in to facilitate smooth and seamless transactions amongst the consumers and the prosumers and other DER participants, it would really help the energy sector leapfrog in its next phase of reforms. That's the overall, but then again, we have seen, and I think Mr. Reggie has been on the forefront in propagating the concept of the P2P, which is the peer-to-peer trade. As regulators, we have raised several questions on him, that you please find out these solutions. You know, another important, I mean, we are missing Abhishek Ranjan here. It would have been good to have his perspective as a distribution company. Is he there online? Okay. So, no, at least here in this session, because see, distribution company or the distribution licensee is the biggest stakeholder in this whole scheme. Because the whole concept of metering, all of you presented the way the transactions will happen, but it would be good, and I am sure FIDE and other agencies are engaged in dialogue with the distribution companies. You know, their stakes, their equity also need to be seen. It's a different kind of a world that we live here in India. We don't have a retail sale competition here. Distribution network companies are also responsible for retail supply. There are cross subsidies that exist between consumer categories. So when it comes to allowing the prosumers and consumers trade between themselves or other entities who would otherwise buy power from the distribution company, and if they start trading amongst themselves, the distribution companies quite often get awed, and then they feel that their financial health will turn into red. And their stake, they are a very, very important stakeholder in this whole game. So while we talk about the technological intervention is for prosumers, consumers, and other participants, we need to see how it fits into the overall ecosystem that we have in the existing, energy sector here in India, because we have to find out a solution which is best suited for the Indian conditions and is designed around the overall market design that we have here. And I would personally look forward to solutions in fact, my basic idea of coming today was to learn more about this technology, because we have been discussing, and we have several regulations which we have come up with called net metering, gross metering, the virtual net metering, so all these concepts are already in place, but then how does the new system fit into this whole scheme is something which, as regulators, we would be looking forward to, and as we go along. So I would stop here and possibly request Mr. Arent for your observations on the theme. Thank you.
Sure, thank you. So I'm Dr. Douglas Arent. I'm from the National Renewable Energy Lab Foundation. So this is affiliated with the National Renewable Energy Laboratory that you may know as NREL. It's a U.S. Department of Energy national laboratory which is focused on the clean energy transition, has been for 47 years. It's about 4,000 people. One of my colleagues or from NREL is in the audience here, who's also a power engineer. That might be interesting to hear comments from. But I will offer some reflections, because we, or colleagues at NREL, when I was there, began looking at distributed energy resources and concepts of peer-to-peer trading, prices to devices more than 20 years ago. And they still are very nascent in the marketplace. And let me reflect, because Mr. Chatterjee's comments, I think, are very important for those not in the energy sector. And particularly, I love the enthusiasm of thinking about data layers, services layers, trading and trading platforms. Wonderful, except for they lay on top of a physical layer. And it is the interface between the physical layer and the data layer, plus cyber, then markets. That physical layer to data layer is the most critical layer that is not shown on the UEI charts, but must be incorporated. And so this is how, in fact, in the United States and other locations, how virtual power plants actually operate today, which is there's a signal from the transmission service operator to the DSO that they actually need demand response or other services provided to the grid in a very fast time frame. That service aggregator can communicate to hundreds, thousands, millions of devices in the right place at the right time to actually provide those services back to the grid. And there is a physical, both a physical attribute that goes with that, and there's a monetary attribute which goes with that. And that's the price arbitrage which makes money. And it's really important to understand that it's both data and physical. And while the UEI on top of that can provide incredible services among customers, if those services affect the physical grid, then something is not in sync as it needs to be. And so there needs to be very close coordination between the prices or the peer-to-peer exchanging, all of the activities there, and of course what are the actually impacts or services offered to the grid. And so I think I was one of the ones that probably introduced this idea of flexibility of all assets in the grid now probably 15 years ago. And it's really thinking about services among customers, meeting or exceeding their expectations, their needs, but also adhering to the physical attributes of the grid. So for example, India is going to see tens of millions, hundreds of millions of new air conditioners coming on board, right? Probably more load than electric vehicles and certainly more load than currently existing. Should those air conditioners be controllable? Likely, very much so. Could you do peer-to-peer exchange between someone with a photovoltaic panel and an air conditioner? Sure, but that's a monetary exchange. The electrons still need to flow through the system. But, for example, the air conditioner in this room, or certainly the condensers, could probably be turned off for a few minutes, and none of us would feel a difference, right? And if that was happening in this room and the building next door, possibly the DSO would then see that they could actually lower demand in this particular region on a given transformer and provide better services back to the total DSO service aggregation or reduce the congestion, et cetera. So a lot of detail in there, but it's the hybridization between markets and what's happening or what's described as the opportunity of UEI and the physical interface that needs to be put in place. And then let me just add one more layer that we're very, very deeply involved in, and I would implore all of you to think about deeply, which is cybersecurity of all of that. And so the utilities want to work in a very secure environment, and having an incredible open data layer on top, which might facilitate peer-to-peer trading, lovely, in the markets, but what's the interface between that platform and the physical platform needs to also have its security on it, and there will likely be cyber regulations coming forward and other considerations as well. So there are a couple of things that NREL's done, and then I'll end. One is to look at the work that we did now probably 7 or 8 years ago on what's called autonomous energy systems. And I think this is really important to think about, because in this peer-to-peer trading concept, one thinks about not distributed energy resources, but decentralized architectures and distributed optimization and control algorithms. And so this is a layer that's well beyond centralized dispatch and control. And we've shown this in simulation to go to tens of millions of devices. And those devices can be photovoltaics, electric vehicles, batteries, et cetera, possibly inside the building. More likely, it's probably the building energy management system, and under the building energy management system, there's lots of arbitrage among the different devices inside the building, whether or not that's a hotel like this or a home. So it doesn't matter. But there's a whole architecture there of mathematics, of control algorithms, et cetera, which are consistent, in fact, with what the DSO needs and the TSO needs, and are consistent with the UEI architecture. And so there really is an opportunity, I think, to unleash this, as well as provide the customer services and the, I'll call it the vision of UEI going forward. So I'll leave it there. There's a lot of work yet to be done to realize this. There's also, I think, the need to leverage platforms like NREL has, which is a very large supercomputer, for example, where you can do digital simulations of assets and physical facilities which have hundreds of millions, if not billions, of devices, which actually needs to be explored in digital twinning in order to inform the regulatory decisions and, in fact, the planning decisions and operating systems of the utilities themselves, i.e. to deal with the physical layers as well. So a lot there. Thank you.
Yeah, thank you. Very useful observations. And in fact, yeah, right from the very beginning, from the first presentation down to this point, I was in fact trying to look at the interface between the infrastructure and the digital layer, because one needs to really, both energy sector as well as the digital sector experts need to pool their resources to find out common solutions which ultimately meet ends on both sides. That's really the need of the hour. But before I move on to the audience or the participants to for an open house questions, I'll request Arshi for your observation.
Thank you so much. So Chatterjee sir, of course we need DSOs. It has all come down to that. And another thing is, of course, if there is a world where we can separate retail from distribution, that is where this perfectly fits. So where UEI, the basic concept stands is, everything is already being done, but it's a one-way communication, where you're asking a customer to reduce the load. Can it be a negotiation instead? We all are coming down to the price discovery of all of these functionalities that we want these assets to perform, but the price discovery is at the helm of anybody who's on the top or whatever think tanks are saying right now. But what will be the willingness for somebody to pay to charge their vehicle at this particular hour when the solar is generating power? So can we just make a sync between those two things? Of course, we are working like on the UPPCL pilot with ISGF right now. Now, ISGF did one very good thing, that they are not treating it as a pilot. They are trying to plan the entire infrastructure that it is scalable to 1 crore people. Now that we're working on the actual infrastructure, we realize the difficulties of it. How do you integrate with 5 MDMs in a single state in order to validate these transactions being happened? So these are the real physical problems that we are facing right now. And no matter what, we have come to a conclusion that a regulator will have to define these things for them. Now with the utilities, we also understand they are the executors of anything you want them to do. The point, whenever we make them the thinkers, it's beyond their bandwidth at this point in time. Utilities are very excited. I haven't come in, so I am, originally I work in solar industry, so I talk to utilities all the time. I don't see any resistance about anything. As long as we facilitate it for them to onboard such programs onto their infrastructure. Even with the best intention, they are not able to map out how do they become a part of a technology as such. And of course, with solar penetration, and a year back, I was on a similar panel, so I had this conversation. A year back, even I was, so since I'm coming from the energy sector, I had my obstructions that this is not going to happen and all of those things. But it took just one right policy in PM Surya Ghar to onboard 10-year worth of effort once, in a month's time. So it's just one policy that takes the exact push that would be required in order to push these things. The system is bilateral. Like people are going to put solar, people are going to buy EVs. How do you incorporate all that into the original infrastructure? Because reliability, as a matter of fact, will always be the most important concern. Thank you.
Wonderful, Arshi. Yeah, we are, and in fact, looking for solutions, and good to learn that you people are working closely with the distribution companies or the infrastructure companies who are actually into this whole scheme. Both Anirban and Mohit, I think your presentations did give us a glimpse of what you're talking in terms of the digital layer. And you mentioned, I think your presentation did mention about some of these terminologies like the demand response and others, which we are quite used to. You know, and what Mr. Arent mentioned, and rightly so, coming from a grid agency. So, see, there is a concept of DSO, which is called, or the, TSO, the transmission system operator, or the distribution system operator. They need to, manage the grid operation, the actual physical flow of electrons. And there are, with more and more, intermittent renewable coming at the large scale, at the grid scale, wind and solar are quite variable in nature. And so you have to, as a system operator, you have to manage the grid. So what they need is what we call flexible resources, which could quickly come and help balance the system. That variability can be managed. Demand response is one such critical element of what we called in, again, energy sector terminology, it is called ancillary services. These ancillary services come and support the grid operation. They relieve the congestion, they relieve the... So demand response. Now, system operator would need it, need these demand responses in real time to come and help them, and there could be a compensation mechanism which, as regulators, we have already been working, and we have that. Now, given this broad understanding about the grid operation, the need for a grid operator for flexible resources like demand response, how do you think your digital platform can help this? If you could just throw light, either of you.
Sure. No, very valid points. First of all, thanks a lot for pointing out, Dr. Arent, the points that you made. It's unlike payments, it's not about adding servers, right? You have your own constraints of the grid. So if you want, you just can't push more energy. So those are the true constraints that we have to live with, and the design has to evolve around that. The hypothesis that we have seen playing in India is these are market structures, and these are also governance mechanisms, which doesn't exist today because the grid doesn't have a way to look any more beyond the meter. Anything happening behind the meter, today the systems, at least in India, Mr. Chatterjee can pull in more views, but it's pretty much blind, right? So if this kind of systems come up, the networks come up, first thing that it will do is it will put all the assets digitally on that network. It will create something called observability. Now it becomes for the grid observable that, okay, this is a hotspot, this is where things are happening, this is where energy is being pushed back. Once that observability is created, then you can create something called a forecastability, a controllability, and so on. Like you said, that the millions of ACs that are coming in, probably it will come with some controllability. If I can put that control, of course, with consent, to the utility through some aggregators, then can we do new things? Of course, keeping the boundary conditions in mind. But coming back to Mr. Chatterjee's point, kind of the similar way, demand flexibility for us looks like a very sweet spot. I mean, 3 days back, me, Arshi, were in this session arranged by RMI to create how to create a national grid flexibility platform. Imagine if UEI plays out. Let's say, an hypothetical situation, there are millions of devices connected to the network. Now, if utility gets an entry point to the same network, the network that I was showing, there are multiple EVs connected, there are multiple batteries connected, there are multiple, ACs connected, appliances, and so on. If the utility gets an entry point, and now he can see all these things digitally connected, and somebody gives a consent-based control to the utility, this demand flexibility, the real-time challenges, the real-time handling of those things basically become kind of real and real-time controllable. I think Arshi has a point. You want to add something? Yeah.
So just to play out a scenario, in one of the cases, like right now we are saying prosumers and consumers, but at the same time utility can become a consumer themselves. So there is a particular distributed transformer. At the same time, they know where all the loads lie and when they want some effect from those loads. At that point in time, normally a utility would signal them to reduce their load, but right now they'll signal them to maybe pay 5 rupees for that particular reduction in time. However, if a network or a real-time negotiation like this exists, a consumer will also have an option to bid back that I will do it for 6 rupees. It may work out from them. It's going to be more of a conversational format at this point. Now, with the smart meter and everything, we've tried, like we've been working closely with 2 utilities at this point in time. It can be planned out, of course, in a where you can bring all of these assets through an aggregator. Of course, this also needs an aggregator market because the individual quantum will be so low. So you want somebody else to come along the lines and keep the end consumer pretty engaged. Also, what we are thinking about this is it's not demand response that has to be 5 or 10 events a year. It can be a daily load management. If you have so many assets at play, it can be a daily conversation if there is a transaction, because through this mechanism, so basic model for a UPPCL thing we were doing is, if somebody were to trade today, tomorrow at this certain block hour, they will bid, I'll sell out 5 units, say. Some consumer is going to buy those 5 units. At the same time, that micro transaction will happen the same day. The consumer will get, so without active involvement into anything, even if you're getting like pennies to the dollar, it will still keep your interest into the whole thing. At the same time, you will become a more active participant on the network. That's going to work out.
Can I just
please.
very, very quickly? There's something very interesting about this. I mean, one of our big sort of principles that I live by in terms of customers is that everything needs to be automated, needs to be super simple, and that customers do not get the rewards of the whole system value of their flexibility. They're only getting the wholesale price. Now, if what you're not having to do is to build big infrastructure because you've got a virtual power plant, the true rewards are not really being delivered to customers, and as a result, they're not totally incentivized, and we need to change that balance. And I would propose you look at Estonia, where actually customers auction their profile to the market. They're in control, and the market comes back to them and says, I've got an offer for you based on their preferences and based on their potential to deliver flexibility. It's super exciting.
Let me just, and I know Reggie has a comment or a question that he wants to bring in, but let me offer maybe a couple of reflections. So one, there have been many experiments about customer engagement in their energy and particularly their electricity. So energy is not just electricity, but we're talking mostly electricity here. Most of them, including things like the Google smart meter or things like that, have failed when they assume that anyone in particular cares about their electricity consumption or their prices, etc. So this idea of automation, of understanding preferences and learning actually each individual customer preferences is very, very important. And that's about intelligence, sensing, understanding individual choice, and or household choice, because you can also architect households as well, which is also very important. The other piece, and maybe I'll just talk about from the US perspective a little bit on ancillary service perspectives, which is ancillary services are well beyond just energy, right? And so one thinks about energy or demand response is not an ancillary service. Demand response is actually about an energy service. And then there are additional ancillary services, at least in our lingo, as we interpret that, in terms of ramping up, ramping down, possibly frequency, voltage support, things like that. So all other things in the electrical energy or the engineering side of that equation, which are actually codified in market signals in certain markets, not all markets. But if one looks at what's happening in California, Texas, and elsewhere, you can see the evolution of markets to reward those, quote, ancillary services, which is well beyond just energy itself. So a lot of opportunity there.
We now throw open for open house questions. Yeah.
Yeah, I'd like to bring everybody on what we are doing in Lucknow, the project which with the UEI architecture. So in 2020, we conducted a very small P2P pilot project. By the time it was approved by the regulator, there was no actual money transaction, there was no regulation, but regulator has given the approval to undertake that. And we wanted to have some 24 people, a dozen prosumers and a dozen consumers. By the time UPPCL did all the paperwork and given to us in end of February, COVID has already come. And there was, although there was why we chose Lucknow, because there was almost half the population had smart meters. But there were some other problems going on with the smart metering. It was not properly commissioned. We didn't want to interfere with that. So we decided to put another smart meter in series with the existing revenue meter. So that we have done. Nobody allowed us to get into anybody's house during COVID wave 1. So we had to wait for 6 months. Finally, in August, September, I personally went camped there, and we had great difficulty. Could get 9 prosumers and 3 consumers into the first pilot we have done. It went very well actually. About 6 months we ran it till March, and then we gave our recommendations in 22 March. At the same time, in fact, before UP, Tata Power Delhi, they wanted to do this pilot project, but we first said we'll do it in a state discom before we do it with a private discom in Delhi. So Delhi, when we did, we had 117 participants, about 60 or 70 buyers and some 50, 60 prosumers. Some of them were Tata Power's own properties, both as buyer as well as substations as prosumer selling it. And we ran it for almost a year. By the time that we commissioned, the second wave of COVID came, and Tata Power was very busy with managing the network. So till November 2022, we ran that. Sometime in 24, DERC issued regulation. So UPERC issued regulations in 2023 April, they issued regulations for P2P trading, allowing it legally acceptable. Those who have rooftop on their buildings can enter into P2P trade. The regulation is very clear, crystal clear, including some sample billing also they have given. The energy, only kilowatt hour considered, energy price is determined between the prosumer and the consumer. Means buyer seller, they will decide what price they should sell. And the blockchain service provider, those who will get 21 paise per kilowatt hour from both the participants. So 42 paise, 21 from the buyer, 21 from the seller. In addition to that, for the network is UPPCL network, they will get 92 paise from the buyer, not from the seller, only the buyer. So these regulations are very clear, and they have issued that it should be scaled up. This pilot was successful. This system should be scaled up so that all consumers in the state of Uttar Pradesh can take benefit out of it. When it came to UPPCL, they said to collect this 21 paise from the prosumer, 21 paise from the consumer, and our 92 paise we will anyway collect it from the in our bill. But aap logon ka paisa collect karke dena is a tough task. We will not do that. So it went on several layers of, and that too they said they have 30 million customers with great difficulty. Billing system has been fixed. Bills started going Prakash is from UPPCL only. So the great difficulty, we have fixed our billing system now for your this small, maybe 1,000 people will enter in 1 year, maybe 500 people, we don't even know. Scale pura billing system reset karna padega, it's going to be a major problem. They resisted for over a year. That's when we got into this UEI thing. We said, okay, now we have a solution. You don't need to do a major changes. We will implement UEI. So in the meantime, Delhi regulation came. Delhi regulation didn't specify the numbers. They said each DISCOM should file a petition when they are ready to do that. Delhi only Tata Power has smart meters. So other two DISCOMs are ready to do smart meter. Without that, you cannot do this. So Tata Power intend to file a petition with the DERC, what should be the network charges which they should get as a wheeling charge, what should be the platform service provider fee from or those kind of details. But now everybody is waiting the UEI implementation in Lucknow, which is almost ready. We would have done it, but for the IT department, they wanted to commission their smart metering system before 31st March. So they are terribly 24/7 busy. We personally went and sat with them, giving support. And also, we identified some prosumers with the net smart meter, which is newly installed. In Lucknow city area itself, we have about Shashi working in that project only in Lucknow. About 50 people we have identified, we have spoken to them. Consumers also we are onboarding. So by middle of April, we'll be able to demonstrate that. So Trillectric, Arshi is one of the platform provider. The blockchain provider is here. I think Ravi Jagannathan and Mohit, they are from KrypC. They are the blockchain provider. In between, 3 pilot projects. I talked about to Delhi, 117 participants, 12 people in Lucknow in 2020. And in 2022, we did it with the Calcutta CESC. There we had more than 1,000 participants. They again, mostly C&I customers. We had only AMR data. Every day night they were downloading AMR data, giving to us next day, so we could do the things next day. So if you recollect, Chatterjee Sub, you had given us a presentation slot to the subcommittee of the FOR a few months ago. So there we explained this, and the regulators from other states with whom we've been talking to, they all are wanting to come and see what is exactly how flawlessly this transaction will happen on the digital layer, in which UPPCL's 92 paise also will directly flow. Like today, according to the regulation, by today evening we have to, tomorrow's trade, those prosumers who want to sell how much in the tomorrow, to finalize into the trade by today evening. And tomorrow's meter data, when it comes in the night, you know who sold how much. Yeah, like I think my rooftop will have 20 units of electricity to sell tomorrow. I put it on an auction saying that I want to sell it at 6 rupees per kilowatt hour. And he has a shop. He today pays 9.5 rupees to UPPCL. He's getting at 6. He'll say, okay, I'll buy it from you at 5.5 rupees. So trade got closed. My surplus going to UPPCL network, I get only 3 rupees now. So I am getting 5.5. So I had to pay only 21 paise to the service provider. And he is getting it at 5.5 rupees, and 92 paise he will pay to UPPCL for the network charges, and 21 paise he pay to the platform provider. This is the metrics there currently existing.
Details we can get into later.
No, I said,
let's give
yeah,
an opportunity
no, all this transaction happening flawlessly. If we agree to buy at 5.5 rupees and 5.5 rupees and 20 units I promised, but 20 units didn't go, only 15 units went. So that we will know only when the meter data comes the next day. All these calculations happens in the blockchain layer and in the digital platforms which will be built by these other participants. We'll be able to demonstrate that this happens flawlessly in April. So other states like Maharashtra, Gujarat, Madhya Pradesh, Orissa, Kerala, Karnataka, they all interested in doing that. So if everything goes well, by end of this year, half of India, there will be enabling regulations, and there will be technology also that people can engage into peer-to-peer transactions.
Thank you. We are looking forward to any, please.
Thanks for very insightful information, not only from Indian perspective, from US and British perspective. And I have 3 points to clarify.
Your throat is okay?
I cannot speak for more than few minutes. That's the problem. So, thanks. So I want to clarify 3 things, and then I have a question as well. One is about the security, what you are referring to. So our the layer, data trust layer, it's highly secured because we use permission ledger. It's not like a public blockchain where you can see everything. It's a permission ledger, and also we have got a strict, authentication to ensure that right participants are in the system. That is number 1. And the second one, you are referring to the physical and the digital side of it. See, obviously, if you see, Madam was talking about the telco as one of the case studies, like happened 30 years ago. There were switches, and then you have to take the data from the switches. That is the difficult part, right? Physical and digital. And it is invisible. The talk time, data, everything is invisible. So how do you achieve that? So there is an experience. They have got some kind of call data registries, and there is a kind of a standard. So that's how the GSMA, the whole world operates. So similarly, in our scenario, we need to bring certain standards. How do we get the data from the meters? Good thing is there are smart meters. It can store some data, it can give you some data, all those stuff. So there is a kind of a signing capability so that the data coming into our system is properly signed by the meters, so we can take it as an authenticated trust data. That is the second part of it. The third part of it, Sir was talking about how do we make use of this data and for various other purposes. Now, the purpose of the layer is to ensure whether it is happening in a retail or in a wholesale, irrespective of that, get the data and then make sure that the data is trustworthy, and also implement certain smart contracts as the regulator prefers. It could be your deviation, it could be your anything that you wanted to say that this is a regulation. A smart contract is a way that we can insist certain standardization. That is how that layer works. Now, coming to the grid discipline part of it, for example, the IEGC, they are talking about 49.9 to 50.05. So for achieving that, we can at least provide the data from this retail transaction. That is what the objective of the data trust layer is. So once if all these things are available inside this ledger, then it is easy for any participating entities to achieve what they want to achieve. That's what we have been doing through our this layer, sitting along with the UEI, the beacon layer. That's what we have been doing. Thank you.
Wonderful. Yeah, I think there is one hand right there. I think out there, yeah.
Thank you very much. It was a very wonderful discussion on future of technology in the energy transactions. I have very quick questions which I will keep it in this way. So as Sir was mentioning some case studies also, there are a lot of challenges in the peer-to-peer transactions and all. And there are a lot of data points. So who should be basically the driving seat as like a service provider? It should be like a regulator or a distribution company, as you are mentioning, like distribution companies are one of the lifeline in this particular stakeholder, or the RESCO aggregators, or any other agency. And there is one more sub-question, like does this digital platform by itself can be centralized or a decentralized? So we are talking about in India, seeing the prosumer category, the energy generation at one point, maybe in the north part of India and south part of India. Are we seeing that in future, like the technology is going to be centralized format?
So I'll take this. The clear regulation is today only in UP. UP has 5 government discoms, utilities, plus Noida Power Company, 6, and 1 franchisee in Agra. So 7 entities are there. So the regulation says that customers in one discom can do P2P within that discom. So we wanted to demonstrate that, and thereafter we'll work with the regulators to remove that. From Lucknow, person can buy from Agra and sell it to Meerut or anywhere. Once that statewide, once we achieve, which I hope will happen in next 2 to 3 or 4 years, then comes the question of doing it in the entire northern region. My surplus in UP I sell to Himachal or to Chandigarh or Haryana. That kind of a thing we should, CRC should look at that way. Thereafter comes North India to South India, South India to East India trade, and then to neighboring countries.
It's not a platform, it's a network. So platform there will be multiple platforms. Anybody can come onto the network. What we are saying is a smart meter data, a solar meter data, everything will be available on a network. Now there will be an aggregator. It can be Paytm, it can be anybody. It can be Amazon if they want to be. They will get that data from the utility through a secured layer, where they can then have an interface with their end customer to basically trade that data. So it's just a network. So network can be interstate, it can be anything, as a matter of fact. The assets will become discoverable. The first thing is visibility of these assets. Now, how do you build a business model on top of it? That the market can decide.
Just a very quick addition, and I keep on going back to the payments example, but it is important to see and unbundle experience from the actual transaction. If you look at the UPI example today, who holds your experience? Your experience is held by a Google Pay or a Phone Pay, who doesn't even have a banking license. The money is held by banks, right? But the banks always fail to give you that experience, and that's why you like to trade through a Google Pay, not to a Yono SBI or say Axis thing, right? That's the market structures probably the market will come up with. Of course, I can't ensure, but that's how we see it. Experience will be held by someone. The actual transaction will be held by someone. So there is no one anchor who will enable this whole system. It is going to be designed in a such a decentralized way.
Should be very simple for the consumer end of the day. Yeah.
That's the basic.
Like the point that madam was making, that it should be automated. I should not even come to the app to say I want to sell 5 units. It should automatically read my profiles.
I actually think that the whole digitalization piece and also the value and demand side response is going to transform the energy sector and turn it into a service sector. And that's what it really needs to understand. It's not just producing a utility, it is enabling the customers to do stuff. And this issue about everybody in the energy sector in the UK wants consumers to become electrical engineers. It's really interesting. That's why they're not getting any engagement.
Anyway, you had a hand raised.
Hi, my name is Pulkit. I'm part of Solar Square, which is a home energy asset company. So I don't traditionally come from the energy world. I come from the digital world. But seeing the revolution which is happening in energy world, so decided to eventually shift here. So a lot of concepts, new energy flow concepts were discussed here, including P2P and VPP. Eventually the UEI or a connectivity layer becomes a base foundation where everything is being connected and is interoperated. But like in my opinion, the concepts which were discussed, so P2P and VPP are kind of complementary with each other, right? So in VPP, what we are doing is an operator aggregates all the different assets, and the surplus is being controlled and then sell to the discom being the retailer again at time of peaks, right? Whereas in P2P, it's the prosumer and consumer who deals with the surplus, right? With the discom just being the facilitator. So is there any method in which the RC is conducting the, whether which energy flow concept to go with for the future of the energy systems in India? Or are we taking any references from the developed markets which have already implemented all of this? Because there are pros and cons to each of these concepts.
I don't know if it's, aimed at me. Of late in India, and at least at the central level, we have been studying international experiences across the length and breadth of the reform initiatives that we are taking in the power sector. And we are confused as to whether there is any concept of a developed market or an underdeveloped market or a developing market. And at CERC, that's the kind of feeling that we have, because more we study, the more confused we get as to whether there is any perfect market model which can, quote unquote, be termed as a developed market. So first, your response to that. Each market is unique in its own landscape, you know. So we can mutually share experiences from each other. And whether any market model, whether it is the P2P model or the kind of other interventions that you are talking about, which succeeded in one market would succeed in your country or not, is something that needs to be studied at length. Not that you have many examples of successful implementation and demonstration of the demand response or the kind of DER engagement across. There are countries, I mean, last month only, in December, we were in Australia trying to look for solutions for, demand response. We heard that we did spend about a week's time out there. We have a regular interaction with the US counterparts. Earlier we had engagement with NREL as well and several agencies. And as I said, I mean, so many, I think Mr. Reggie also gave examples of how he's trying to make this P2P work in UP, in one of the states. Now, again, as I said, there is an element that you need to understand. While we have these kinds of examples elsewhere in the world, and some of the presentations did, I think Ms. Laura's presentation also talked about the interface amongst the consumers that is possible in UK. And these digital, not platforms, networks, I correct myself. Networks can really help and do that easily. But when you translate that into Indian realities, you will have to overcome several other challenges, which I briefly mentioned, and especially for people who are not from the energy sector, would need to be aware of this. And I did mention succinctly that DISCOM is the biggest stakeholder. Distribution company in India is the biggest stakeholder. And they are a load serving entity, but they cannot be, their structure and business model that exists in India cannot be compared to the kind of load serving entities that you might be having in your quote unquote developed countries. Here, the example that Mr. Pillai gave, I would say that it would take years for that to succeed. The example, for instance, what did he say? That there is a consumer who is otherwise getting electricity from a local distribution company at 9 rupees. Now he sees in this network that there is another prosumer who is ready to offer me at 6. So what would he do? I mean, naturally, my propensity as a consumer would be to buy from that prosumer and not from this distribution company. The distribution company will never let you do. There would be, because there is an cross-subsidization in the tariff that exists in India, which is unique to India. The point that I am saying is that you have to find out a solution. So there would be, that is why I have again been urging that distribution, you have to make them feel that their equity, their stakes are being taken care in this whole scheme, apart from the technology and the physical infrastructure and the electron flow. Another critical element which is unique to every country and unique to India is this important element which are parts of the overall market design that you have in the energy sector. And those realities need to be factored in before we jump into elation that we have really done. This is something really good, and the need of the hour, whether you want or not, this will happen in India. I mean, I am saying, even as, a person coming from the energy sector, these revolutions, possibly no one can stop from happening. But if you want to hasten, if you want to really expedite this process to happen in India, what you need to do is to understand the nerve of the sector. Address those things and then take this forward. Sorry, last question we can take from the audience because I think we are almost, yeah.
Okay. We heard a lot about discussions on different architectures, and 2 quick points. If the proof would be eventually in the pudding, and eventually the people who are operating the system would have to be taught how to operate this new system paradigm. And if we compare the analogy with a critical infrastructure, let's say a flight, what we are talking about here is essentially doing a software and a hardware upgrade on a flight while it is mid-air. So my fundamental question is, does it not make sense to also develop an emulation where all these architectures are actually tested, validated, and because eventually it would come down to scale. Even if this pilot has given us good lessons from 10 or 11 people, the next pilot and the pilot after that would take some time. So why not take those lessons together and do all of that at scale, which, I mean, HPC is very cheap. Computing is very cheap. So why not take a benefit of that and implement all these ideas at some scale?
I can respond. I mean, I completely agree with you that, I mean, I really like that analogy, but we have seen this playing out multiple times. So I'm more than confident that it can be done. But the principle that I was mentioning, that it can't be done overnight. You can't go to the operator and say that, okay, now you have to do this. Even if it comes from the regulator, they're going to, of course, oppose. So it has to be in a +1 method. Like you said, you have to give them pilots, which gives them confidence, which shows them, which are actually real pilots. It's not shadow billing, it's with actual billing, actual recovery that, okay, this thing is working, and then you scale it from there. Though the target is to scale to a 1.4 billion, but like you said, it can't start from 1.4 billion. It has to start from some smaller scale up, and that would be my opinion. But if anybody wants to add.
Thank you. No, I think in the interest of time, I think we'll wind up, but would request each of the panelists 1 minute each, if you could give your last and final thoughts.
Encourage more conversation and active discussion between those working in the, I'll call it the digital sphere, and those working in the physical sphere. And if we can be of assistance, please reach out.
Wonderful.
I would like to urge people to think about other sectors and learn about their journey, because actually I think we can learn a lot of a lot of their mistakes, and we can accelerate. And I would say, picking up on your point, that there is a huge amount that has been piloted in all parts of the world, and I have a resistance, and I call it pilotitis, that nobody moves forward unless they've had 10 pilots, and innovation dies on the back of that.
Very nice way of putting it. But yeah, I agree with both of them, and I would love to see that bridge coming, because definitely we come with the expertise and experience of the digital world, but there are very nuanced things about the sector which we sometimes miss. So I mean, definitely agree with Dr. Arent that we should have more discussions before we jump into conclusions.
Yeah, so to me it was like a great learnings now and experience from various observations, right? Like we are confined today's discussion more about P2P. I want to just think beyond it, like from the current context. Let me at least assume that, okay, we will be reaching 70 to 80% target in few years, or 5 to 10 years, whatever it is that everyone is involved in P2P. And what today we don't have, and where we are heading in P2P, is the trust layer, observability layer, and the inputs. What we have, at least for future design, we should keep them into consideration, like something like digital twin. Like today's data we have, and if we can not only leverage the compute infrastructure which we have availability today, plus the various AI models, etc., like from your previous query also from you. So we could definitely start building those infrastructure, those resources, that we are able to simulate what's going to happen tomorrow. Even though we are not able to connect with the physical infrastructure at present, and we can believe that we'll be able to bridge that gap at some point of time, but we can provide them a lot of information that tomorrow, based on this information that is going to happen, plus the discrepancy, I would say, how the weather dynamics is changing. It could be a different challenge in 5 to 10 years, because it's raining and somewhere suddenly weathers are changing, right? So solar may be advantage, and it may also create this trouble. So with these models, we would be able to better optimize the networks and work forward. So I would think let's focus on our current areas, but try to have the architecture for the future support. Using all this.
Thank you, Arshi. 1 minute for you.
So just to expand on what you said, the problem is there is a left-hand side, which is a physical grid, and there's a right-hand side. both are in silos doing their best job. They can scale up to whatever computing power you want them to, but how do they work together? So on top of the digital energy guide, we also need how do you integrate this physical energy with that digital energy grid? So I think most of the integrations or standards or regulations should start putting this load at least on a network where it can, but let it be market ready, that's it. Then let the market decide. Thank you.
Thank you. 1 minute for myself as well. So, yeah, I think all the panelists have rightly summed up. There is a big urge to work together, you know. I mean, the only thing that I would say is that when the digital world comes to this physical infrastructure world, the people in that infrastructure and the physical world should not see digital world as an outsider. How you become an insider and become an integral part of the whole system is something that is really the need of the hour. These things, as regulators and of course as central regulator, Mr. Pillai has been in touch with us. We have always been forthcoming in learning new ideas. So how to translate that into reality is something which we would look forward to through such interactions and dialogues in future. And thanks a lot for providing us this platform.
That's the very reason we insisted on bringing you for the session.
We'll start with our moderator. Thank you so much, sir. You moderated the session very well. A big round of applause for SK Chatterjee, sir. Anirban Sinha from FIDE. Thank you so much, Anirban, for joining us. Miss Laura. Thank you so much, Laura. Miss Doc Arent. Thank you so much, sir. We have Mohit from KrypC. And Arshi from Trillectric. Thank you so much, Arshi. Requesting everyone for a group photo, please. Raviji, please join us. Vani from Kazam, our project partners, please come forward. Abhishek, you also please join us. Our partners from Thank you so much. Requesting everyone to please proceed for lunch.